Let's take a look at putting ions together to make salts. Now, in chemistry, a salt is an ionic compound, a compound that's made from the cation, the positive ion, and the anion, the negative ion. So we'll look at putting some ions together. Just as a super quick recap, if we had something like the magnesium atom that will lose 2 valence electrons, it lost 2 negative charges, it becomes Mg2+. Something like the nitrogen atom, when that reacts to get 8 valence electrons, it gains 3 electrons, and so it becomes N3-. Now this first one is the magnesium ion, and the second one is not the nitrogen ion, it is the nitride, because the ions that finish with a negative, the ending of the word is IDE, right? So nitride, whereas the first one was the magnesium ion. Now these are examples of monatomic ions, as in one atom, so monatomic. Then we have polyatomic ions, things like PO4 3-, we've got NH4+. NH4+ is the ammonium, PO4 3- is the phosphate. If you see lots of O's attached to something, make it an 8. For example, a carbon with some O's there, that's carbonate. So these are polyatomic ions. Now, I have another video on what ions are. The link to that video is in the description. But let's look at putting these ions together. We started with a magnesium and a nitrogen. Let's use that one. So we have magnesium. We want to react it with nitrogen. Now nitrogen is a diatomic gas. It comes as N2. So we want to know, what are these two things going to make? What is the formula for magnesium nitride? Well, it's going to have a magnesium there. It's going to have a nitrogen there as well. The thing is, how many magnesiums do we need and how many nitrogens do we need? Well, you could do it the long way. Let's do it that way first, and then we'll show you the much quicker way. So magnesium is number 12 on the table. It'll have 12 protons, 12 electrons. Its electron arrangement is going to be 2, 8, 2. These two are going to bug out. It's going to lose those two, which is why that gives us the magnesium ion as Mg2+. Nitrogen, on the other hand, is going to gain electrons. Why is it going to gain? Because it's number 7, so it's got 7 protons, 7 electrons. Its arrangement is 2, 5. It will need to gain 3 more electrons. If it's gaining 3 more electrons, it's coming as N3-, because it picked up 3 electrons that picked up their negative charges. So these are the 2 ions that we have. So we can work out what the charge is, right, like that, or we can just say, hey, you know what, magnesium is in group 2. Anything in group 2 forms a 2+ charge. All right, nitrogen is in group 15, and anything in group 15 forms a -3 charge. Nice little quick way to work out what the ions are there. But anyway, so there we've got our ions. Now we want to put these two things together. The thing is, compounds don't have charges, right? So at the moment, we have 2 positives and 3 negatives. They are not going to all cancel out. We have got too many negatives. We need some more positives. So okay, let's have another magnesium atom kick off its 2 electrons. There we go. So now we've got some more pluses, yay, but now we've got too many positive charges, we need some more negative. Well, okay, let's use another nitrogen atom and get another nitride ion. There we go, now we've got more negatives, but now we've got too many negatives. We need some more pluses. Well, let's just use a magnesium. There we go, now we've got more pluses. Goodness, we could keep going on for a long time, except we don't now. We can stop, because now altogether we have 6 negative charges, and we have 6 positive charges. So we've got the same number of positive and negative charges. Now we can put them together, right? So we go back to this thing and we think, well, how many magnesiums did we need to use? Well, we actually needed to use 3 of them, didn't we? And we needed to use 2 of the nitrogens. This is now the formula for magnesium nitride, right? Mg3N2. Okay, because as we see here, if we go back to this one, we needed to use 3 magnesiums for 3 magnesium ions, and we needed 2 nitrogens for 2 nitride ions. So that's what this formula is actually saying. It's saying we actually need 3 of this atom, 3 magnesiums, and we needed to use 2 of this atom, 2 nitrogen atoms, to make our magnesium nitride, right? That's how we got that formula there. Now, there is a quicker way, a faster way, And so let's look at it that way now. We want to make magnesium nitride. We ask ourselves, what ion does it come from? Well, we could do it the long way, the whole, well, let's look at how many electrons, work out the electron arrangement. What does it need to do? Is it going to gain or lose? How many is it going to gain or lose? Or we could say, well, magnesium is in group 2, so it forms a 2+. Nitrogen is in group 15, so it forms a 3-, right? It's a nice little shortcut there, yeah? So just to iterate that shortcut, let's say this is the group, and you should label these things above your periodic table, right? So group 1, group 2, group 13, what have we got? 15, we got nothing for 14, 16 and 17. Now, what charge does it form? Let's write that down. Forms a charge, and like I said, it's always good to write above your periodic table. Anything in group 1 forms a +1 charge, anything in group 2 forms a +2, group 13 forms a +3. And then we skip group 14 because that actually, they don't form ions, they form covalent bonding, sharing of the electrons instead of electron transfer, so we just skip over them, and then we go -3, -2, -1, and of course nothing for group 18 because the noble gases don't react, right? They've already got their valence electrons that they want. So, Grant, this is a good thing just to write above your periodic table, right? Above each group, just write, hey, these elements form this charge when they make an ion. So then we can go straight to the Mg2+ and the N3-, right? So that's one shortcut. The next shortcut is called the drop and swap method. If the size of the charge is different, and in this case you'll note it is, that size drops and swaps. So that 2 for the magnesium comes down, it drops, and then it swaps, and it's over by the nitrogen. So that 2, let's just do that now, that 2 has dropped and swapped, and it is now here. That 3 from the nitrogen also drops and swaps. So it drops down here and it swaps over to the magnesium, and so it is now over by the magnesium. So there we go, Mg3N2. The 2 was from the Mg2+, but it dropped and swapped. It's now with the nitrogen. The 3 was from the nitride, the N3-, but it dropped and swapped. It's over with the magnesium now. So that's the drop and swap method. Okay, let's do another example. Let's make some, what shall we make? Some calcium oxide. Let's make some calcium oxide. So we're going to take our calcium and we're going to react it with oxygen. And we're going to make some calcium oxide. What is the formula for calcium oxide? Well, what ions are we working with here? We are working with Ca2+. I know that it's 2+ because calcium's in group 2. It forms a 2+ charge. And we've got oxide, that's a 2-. How do I know? It's in group 16. It forms a 2- charge. Well, the size of the charge, if it's different, we drop and swap. If it's the same, and in this case it's actually the same, if the size of the charge is the same, you just put them together, because when we put these things together, these 2+ will cancel out those 2-. We won't be left with any charge, which is good because compounds don't have charges. So calcium oxide is just CaO. All right, no drop and swap because the size of the charge was the same. Let's have another example now. Let's make some, what shall we make? Aluminium fluoride. Let's do that. Well, if we start with aluminium, then we're going to get the 3+ charge on that for the aluminium ion because aluminium's in group 13. Fluoride, well, fluorine is in group 17, so that's going to form a 1-. Now, the size of the charge is different. We are going to drop and swap. AlF, now that 3 has dropped from the aluminium, it's down the bottom, and then it swaps over to the fluorine, it's here. And that 1, of course, from the fluorine drops and swaps, but it's like algebra, we don't bother writing the 1, so there we go. That is the formula for aluminium fluoride. Now, if we were actually writing an equation, we would, of course, have to balance. Like this equation here is not finished. Okay, that is the formula for calcium oxide, but that equation is not balanced because we started with 2 oxygens. We have to finish with 2 oxygens. We can't just do this because we already worked out the formula was CaO, not CaO2. So what do? Well, we have to balance. If we need more oxygen, let's have 2 of these calcium oxides. But now we've made 2 calciums and we only started with 1. Well, let's start with two calciums. So there we go. That is now a balanced equation, right? Anytime you write an actual equation, you must balance it. Going back to this one actually wasn't balanced because this says we need 2 nitrogens. Well, fine, we started with 2 nitrogens, but we need 3 magnesiums. Well, fine, let's start with 3 magnesiums. There you go. That is now a balanced equation. So just keep in mind when you're writing your equations, you must always balance them. But this video really is just on how to put these things together to get the formula. So like if we wanted to make calcium phosphate, let's make calcium phosphate. Well, Ca2 plus is the calcium ion. Phosphate is PO4 3- ion. Now, the size of the charge is different. We're going to drop and swap. So that 3 is going to, when we put these things together, that 3 is going to come down and swap over to the calcium. There we go. The 2 from the calcium ion is going to come down and swap over to the phosphate. So we're going to be PO4 twice. Now, the thing is, that might look like Ca3PO42. That's a lot of oxygen. Goodness me. No, that's not right. We don't use 42 oxygen atoms. Okay, this drop and swap method works exactly the same for these polyatomic ions as it does for the monatomic. The only thing we need to remember is to group the polyatomic ion by using brackets. The phosphate is PO4, that 2 from the calcium dropped and swapped, and it's here. So we don't want to say that we had 3 calciums, a phosphate, and 42 oxygens. What we want to say is we needed 3 calcium ions and 2 of the phosphate ions. Now, phosphate happens to be PO4, but we needed 2 of those. Okay, so the drop and swap method works exactly the same for polyatomic ions. We just need to remember to group those ions with brackets there. Okay, let's just do one more example with 2 polyatomic ions. Let's hook up ammonium with, what should we do, sulfate. So we're making ammonium sulfate. There's the ammonium ion. Here is the sulfate ion. The size of the charge is different. We've got a 1 and a 2, so we're going to drop and swap. So we're ending up with ammonium, which is in brackets because that 2 is going to drop and swap. So we want to say 2 ammoniums. We don't want to say NH42, right? Not 42 hydrogens, but 2 NH4s. And then the sulfate, of course, we don't actually need brackets in this one, even though it's a polyatomic ion. The number that's dropping and swapping is a 1. So we don't write it, it's like algebra, but the 1 is not going to change. We don't have to do, I've got to bracket that and then drop and swap the 1. All right, that doesn't actually change anything at all, does it? So we don't need to worry about brackets for the sulfate there. So there we go, that's the formula for ammonium sulfate. So there we go, that's how we make salts, how we put the ions together. Another thing to just keep in mind is that we always put the positive one first. We talk about sodium chloride, right? That came from the sodium ion and the chloride ion. Now this is a salt, right, an ionic compound, which happens to have the common name of salt, right? That's your table salt, your sodium chloride. But that's what we talk about. Sodium chloride is a yes. We never talk about chloride sodium. That is a no. All right, we always put the cation first. The positive ion comes first. So sodium chloride, not chloride sodium. So there we go. That's putting ions together to make ionic compounds, also known as salts, one of those which happens to be called salt. So use the drop and swap method. The 2 shortcuts really, I would suggest. 1, just go straight to what the ions are formed by, writing the little numbers above your periodic table. You're in group 15, you form this charge. You're in group 2, you form this charge. If you forget that shortcut, you can work it out from the electron arrangements. And the other shortcut is if the size of the charge is different, drop and swap. If the size of the charge is the same, just put them together. So by following the drop and swap method, all charges are gone. Sweet.
Don't forget to hit the like button. Yeah. And subscribe too. It's up here. And here's another video.